Solving by elimination. So elimination is motivated by two main ideas. One, we know how to solve one variable equations, and two, you can add the same thing to both sides of an equation. You notice I use the word equal here, and that's because just because we're adding the same thing to both sides doesn't mean they have to look the same. If I add 2 to the left side, I can add 1 and 1 to the right side. Or if I know that x equals 7, I could add x to the left side and 7 to the right side. So what we're going to do is we are going to start adding equations together. If we have this system, we're going to start adding these equations together. Now, this is 1x plus 4x is 5x. This is negative 5y minus 5y is 0. And negative 3 plus 38 is 35. Now, we can divide by 5, and y equals 7. Now, that's not our final answer, but take a moment to appreciate how much faster this is than solving by substitution. Specifically, if these two things will add to 0, you eliminate the y component of the equation, and then it's very easy to say, sorry, that's not x, x equals 7. Now we can plug this back into either one variable equation. So x plus 5y equals negative 3. X was 7, so 7 plus 5y equals negative 3. Now we subtract 7 from both sides. 5y equals negative 10. Divide by 5. Y equals negative 2. So this is a method of solving by elimination. What we do is we determine which variable to eliminate. We get the coefficients to be equal and opposite of each other. So what we had here was we already had them set up, so it was 5y and negative 5y. Add the equations to get a one variable equation, solve the one variable equation, and substitute back into any two variable equation to solve for the other one. So here, what we want to do is we want to get them to be equal and opposite. So one thing that we could do is this one is negative 1 and this is negative 2. If I multiply this equation by negative 2, then this will have a positive 2b, which will cancel out with the already negative 2b. So I can just leave the second equation alone this time, and I'm going to distribute negative 2 into the whole thing. The reason I'm multiplying by negative 2 is so that these will be equal and opposite. That was what it said. Get the coefficients to be opposite of each other. So negative 2 times 3a is negative 6a. Negative 2 times 10 is negative 20. And now we can add these. Negative 4a, this adds to 0. Negative 16. These should add to 0, otherwise we've done something wrong. Now we divide and get a equals positive 4. Now it's easy to substitute back into one of the equations. Say 2 times 4 minus 2b equals 4. 8 minus 2b equals 4. Subtract 8. Negative 2b equals negative 4. Divide by negative 2 to get b equals 2. There we go. Here, what do we need to multiply by? Well, we don't need to multiply. Because these are equal and opposite already, we can just add. So 2x plus 3x is 5x. Positive y and negative y add to 0. And 9 and 16 add to 25. Now we divide by 5. So x equals 5. Substitute back in. 2 times 5 plus y equals 9. So 10 plus y equals 9. Subtracting 10 gives y equals negative 1. 5, negative 1. Now, are these equal and opposite? No. We could do some multiplying to get the y's to be equal and opposite, but it'll be easier to get the x's equal and opposite. This is 1x, and so is this. So if I multiply one of them by negative 1, then we will have a negative 1x and a positive 1x. X minus 2y equals negative 9. The second one is negative x minus 3y equals negative 16. When we add these, we get 0, negative 5y, and negative 25, which now we can solve. Y equals 5. And then plugging back in, x plus 3 times 5 equals 16. X plus 15 equals 16. Subtract 15 from both sides. X equals 1. So 1, 5 is our solution. All right, here we should multiply this one. In order for these to be equal and opposite, I need to multiply this by 4. That will give me negative 4 and positive 4. So 8x minus 4y equals 36. Leave the second one alone. And now we can add. 8x plus 3x is 11x. These add to 0, and these add to 22. Dividing by 11 gives x equals 2. And substituting back in gives 3 times 2 plus 4y equals negative 14. 6 plus 4y equals negative 14. Subtracting 6 from both sides and dividing by 4 gives y equals negative 5 for our point of 2, negative 5. Last one. This one is trickier, and it's chosen because it's trickier, is that 3 times any positive whole number doesn't give us 4, and 3 and 8 aren't multiples of each other either. So what we'll need to do is we'll need to multiply both equations. What I'm going to do is I'm going to pick something that's a multiple of 4 and 3. So what's the smallest number I can think of that's a multiple of 4 and 3? Well, 12 is a multiple of 4 and 3. So if I can figure out what to multiply by to get this to be 12x and the the second equation to be negative 12x, then that will work. So what do I multiply by? If I multiply by 3, 3 times 4 gives us 12. So now we'll multiply all of the not numerator, the first equation by 3. The second equation, 4 times negative 3, will work. So then we multiply that whole equation by 4. So 3 times 4x gave us 12x. 3 times negative 3 is negative 9y. And 3 times 25 is 75. 4 times negative 3 is negative 12x. 4 times 8 is 32y. And 4 times 10 is 40. This adds up to 23y. Yes, 23y equals 115. Dividing by 23 on both sides gives y equals 5. Now, it's just the same as all the other systems. We're substituting it back in. 8 times 5 is 40. Now we subtract 40 from both sides. And lastly, divide by negative 3. So our solution here is 10, 5. Thank you.